Okay, we're going to work on number 3 from that review, and we're going to keep going from there. This guy is a fraction, and we're trying to take an integral of it. If you try and take an integral of a fraction, you are going to be very sadly disappointed because there is no quotient rule for integrals. We want to rewrite this integral in an easier way to manage, and there's a couple ways to do it. One way is to split this up into 2 separate fractions. We're allowed to do that because the denominator only had 1 term in it. Okay, some of you guys might prefer to do it this way instead. So this is a choice, one or the other, where it's like x to the 5th minus 3 times x to the negative 2. So you bring up the x to the 2nd power, and then you distribute the x to the negative 2nd power. So either of these is the exact same thing, just different methods. You choose which one you want to do. Either way, the first fraction or the first distributing turns into x to the 3rd power minus 3x to the negative 2nd power. Then the dx at the end. We don't want to leave the fraction with like the exponents on the bottom. We want to have them have a negative exponents. Okay, and from here, this looks kind of like a polynomial. So yeah, this is something we can absolutely take an integral of. You cannot plug this into your calculator because we don't have the limits, the a and the b. So you have to do this one by hand. We're looking for the equation, the function-y bit. What do we do? Just like for the x cubed, how do we take the integral of that?
Add 1 to 3 and then divide the coefficient by the exponent.
Fantastic. So the 3 goes up by 1 to become a 4, and then the old coefficient was a 1, so we'll divide 1 by 4. Beautiful. And then we'll do the same thing on the next one. So this will be x to the negative 1. And we'll take negative 3 and divide it by negative 1 and get a positive 3. Okay, this of course could be rewritten as 1/4 x to the 4th plus 3 over x. So if this was multiple choice, it's very likely it would be rewritten in that manner. Okay, but there's a problem. We're missing something. What are we missing?
The plus c.
Yes, plus c. So after you take that integral, you should have a plus c at the end of your answer. So either one of these guys would be totally fine. Okay, now I had somebody last block ask about what about that natural log thing? We're going to see a natural log problem in the future, like on another one of the problems later down on the page. This one was not a natural log because the negative exponent that we had was a negative 2. Okay, it's only if you're trying to take the integral where the exponent is a negative 1 currently. So like integral x to the negative 1 dx, like that. When we finally do get to our x to the negative 1, we don't have to take any more integrals, so there's no issues there. We don't have to think about logs. All right, any questions on number 3?
Not really a question, but could you push that down? Oh, you just did.
Oh, yeah, I'm going to do that like every time we switch problem sets, but...
Okay. I was having some technical problems. Thank you.
Gotcha, no problem. Alrighty. Next problem set is here. Okay, we're going to start with number 4. I'm going to work it out kind of below. We have the integral from 3 to k of a polynomial function, 2x minus 5 dx, and that equals 2. And we want to figure out what could k possibly equal. What could k possibly equal? We'll just get rid of this bottom stuff. All right, can we take the integral of 2x minus 5? Like take the antiderivative of that? Yeah, we can definitely take the antiderivative of a polynomial function. So let's go ahead and do that. If we take that integral of 2x minus 5, using the steps we just talked about, we would increase our first exponent by 2, or by 1 to get a 2. And then 2 divided by 2 is 1. Minus, if there's just a constant, it's going to be the constant with an x next to it. It's pretty common. And then we would have a plus c usually. We do not have a plus c because we've got the 3 and the k. So I'm going to put the 3 down below in blue. Or not. In blue. Thank you. All right, and then up above, let's use pink for K. I'm going to work vertically. So this is going to be the bracket thing. So it's something squared minus 5 times something. Remember these? Minus, and then your second set of brackets. Something squared minus 5 times something. Bracket. So these guys get 3's, and the first guys get k's. Okay, let's work this all out. The pink is k squared minus 5k. There's not a lot we can do with that. We were told to solve for k, so we know we'll have like k equals something at the end. Blue brackets, we've got 3 squared is 9, minus 5 times 3 is 15. So this is k squared minus 5k minus a negative 6 turns into a plus 6. Any questions on any of that stuff so far? All right. Well, the right side of this equation is a different number, right? We've got that whole thing that we just took the integral of, that whole thing equals 2. So I'm going to bring down an equals 2 at the right-hand side of every single one of those lines. We've got k squared minus 5k plus 6 equals 2. How are we going to get k? This is no longer calculus. Go ahead.
You set it equal to 0.
Yeah, we want to set this guy equal to 0. Currently, it equals 2. So how do we make it equal 0?
Move the 2.
Yeah, so let's subtract 2 from both sides. That was intense. Subtract 2 from both sides, and we get k squared minus 5k plus 4 equals 0. Now what? Factor, yeah. This is shortcut factoring because a is 1. So it's going to be k and k. Looks like a minus 4 and a minus 1. Okay. In order to factor and set your factors equal to 0, your equation has to equal 0. That was an issue that I saw on the previous test. I don't know if you guys were just like frustrated at the point where you finally had to start factoring or what, but you got to have it equal 0. Okay, then you set each factor equal to 0, and k would equal positive 4. Set the second factor equal to 0, k equals positive 1, and you are done. That's what it asks you for. Okay, what questions? All right, next problem then. Okay, the next problem says that a function f of x is such that f of x is greater than 0, f prime of x is less than 0, f double prime of x is less than 0 on the interval from 2 to 6. Which of the following statements can be made about Riemann sums, blah, blah, blah. Okay, so for over approximations and under approximations, really what we just want to see is a picture. What does our graph look like? And then we can make some rectangles and see if the rectangles fill up more or less area than the area that's under the curve. We are told 3 pieces of information. We are told that f of x is greater than 0. It is positive. We're told f prime of x is less than 0. And f double prime of x is also less than 0. Okay. So if we're trying to graph f of x so that we can draw rectangles under it, what does that first piece of information tell us? F of x is greater than 0.
That's positive.
It's positive, yeah. So on the graph, f of x is going to be always above the x-axis. So we're going to draw above the x-axis. Second part, if f prime of x is negative, what does that mean for f? If f prime is negative, tell me about f. So f prime is slopes, right? Slopes of f. So every single slope of every single tangent line of f would be negative. Negative slopes. That sounds a lot to me like a decreasing function. Okay, so if f prime is negative, f is decreasing. Okay, and then the last thing they tell us is that f double prime of x is negative. What does the second derivative tell us about f?
Does it tell us the concavity or point of concavity?
Yeah, concavity. So points of inflection happen where concavity changes, which has to happen where like your second derivative is 0 or undefined. So it's this right here tells us that our second derivative is negative. Okay, is the second derivative being negative concave down or concave up? Which one of those is it? Well, hopefully you guys are thinking that f should be concave down. Okay, so second derivative is negative, f is concave down. So notice that every single one of these always referred back to the picture of f. What is f supposed to look like? So I'm going to draw a concave down picture. It looks like this. That takes care of the third requirement. The second requirement is that f is decreasing. So that's just this part right here. So I'm going to erase the left-hand side to get rid of the increasing half of a concave down graph. And the last thing is that f of x is above the x-axis, so I'm going to draw an x-axis below it. Okay, this goes from 2 to 6. Okay, now there's 4 things for this. There's A, B, C, and D. I'm going to recommend you draw out that little curve 4 times, one for each one. One for A, one for B, one for C, one for D. Or for each type of approximation. So we've got a left, a trapezoid, a right, and then left again. So you can use the same picture for A and D. Okay, are there any questions about how we got this picture, that curve? Okay, so I'm going to have that same picture 3 times. Draw it there, I'll draw it here, and I'll draw it here. Okay, this is going to be a left hand. Okay, left-hand approximation means you start on the left side and draw straight up until you get to your function. Then you draw to the right, and then you draw down. I'm just going to make 2 rectangles because that's not very many rectangles to draw. Okay, then from the left again, and I move down. So on both of those rectangles, the top left corner is touching f of x. Okay, for our 2 rectangles, is that an over approximation or an under approximation of the area that's under the curve?
Over.
Yeah, over, because there's extra area in those blue rectangles that's not underneath the curve. Okay, so we know that D is wrong, and we know that A is right, but this could be one of those problems where it's like, is it A and B, or A and C, or all of the above, or something like that. Okay, so if it's one of those types, you will definitely want to check the others. I mean, I would definitely check the others just to make sure that you didn't mess up somewhere. So second one, I'll do purple for B, trapezoidal. So I'm going to draw a trapezoid. Let's draw 2 trapezoids. Okay, for trapezoids, both corners touch f of x. If I shaded in those trapezoids, would that be an under approximation or an over approximation?
Under.
Under, fantastic. So B is incorrect because it said over and it's under. C is the last one, right-hand Riemann sums. I'm going to do those in, how about green? I start on the right-hand side, go up until my curve, then go left and then down. From the right, go up to the curve, go left and then down. If I filled up those green areas, that would also be an under approximation. So C is incorrect. Okay, it doesn't matter that I only picked 2 rectangles. I could have picked 1 rectangle or 12 rectangles or whatever. So as long as you draw your picture correctly, it doesn't matter how many rectangles. It will always be either under or over for that picture type. Any questions on number 5? Okay, I got that pushed out to you. Let's take a look at number 6. Okay, after we talk about 6 and 7, we can talk about 8, because 8 is using what we did in 6 and 7 to just kind of think about things. Now, there will not be a question like number 8 on the test specifically, right? I'm not going to say write as many things as you can think of that talk about velocity and position and all of that. that would be a little bit insane and not specific enough for like asking you what you're supposed to do. All right, so number 6. Picture to the right is a graph of f prime of x. So I'm going to put f prime over there on the graph. It is the derivative of the function f of x. Since we know that f prime is the derivative of f, we know that f had to be differentiable. Cool. That means that f is continuous. Yay. We also can see that f prime is continuous. Sweet. Use the graph for questions 6 and 7. 6, if f of 1 is 4, what is the value of f of 5? We've seen these all over the place. This looks a lot like fundamental theorem of calculus. So to set this up, we are going to do that f of 5 minus f of 1 thing. Okay, I set that up on the right side, and then that helps us draw out the integral on the left. Okay, this integral is going to go from 1 to 5. The dx is going to go last. And inside has to go the derivative of f, which is f prime of x. Right? If you take the integral of f prime of x, you get f of x. And that's what we have over here. Okay, the left-hand side, the integral of f prime from 1 to 5, we're not given like a function to take an integral from. We're given a graph of the function. So we're going to find an area. This is the area under f prime of x between 1 and 5. So I draw between 1 and 5 on the x-axis and then draw up until we get to that function, which was f prime. And we need to find this area. Okay, what are the two shapes that we have? We have a rectangle and a semicircle. The rectangle has area of 12, and the semicircle, we have to find the radius. The radius is 2. So the area of the whole circle would be pi times 2 squared, right? Radius squared. So it'd be 4 pi for the whole circle. This is only half of the circle, so its area would be 2 pi. F of 5 is the thing that we don't know. And we do not know f of 5, but we do know that f of 1 is 4. So we're going to add 4 to both sides. That gets added to the 12. So we get 16 plus 2 pi equals f of 5. And that is B. Any questions on number 6? Okay, 7. Which of the following statements is true or are true? We just did a problem kind of like number 3, so let's go ahead and start with number 3 down here. We're going to find the area between -3 and 1 of this graph. -3 and +1. I'll do this in blue. So here is f prime. We're going from -1 to, or sorry, -3 to +1. Right, -3. Ooh, I went too far. And then -3 is here. +1 is here. And I'm going to split up that below the x-axis area into a rectangle and a triangle. Okay, hopefully we see that those two triangles have equal area, but one is above the x-axis and one is below the x-axis. So if we add together those two areas, what number do we get? We get 0. But there is still that little rectangle down there. Its area is 6 because it's 6 boxes, but it's below the x-axis, so that is -6. So number 3 is true. Questions on number 3? Okay, we can go back up and do numbers 1 and 2. This is talking about f of x being concave up and decreasing. Okay, if f of x is concave up, that means, so this is f of x, f prime of x, and f double prime of x. If f of x is concave up, that means that f double prime is positive. Now let's think about this. F double prime is the slopes of f. So if f prime has positive slopes, that means that f prime has to be increasing. This is all for number 1 here. Okay, is f prime, the graph that we have, increasing between x equals 3 and x equals 5? That is here to here. This is what was drawn for us. Nope, that is definitely decreasing, which would mean that f double prime is negative and f is concave down. We do not care whether f prime is concave down. It just happens to be concave down. We don't care. Anyway, number 1 is false. So A is wrong, B is wrong, C is wrong, so it's got to be D, which means that answer 2 has to be true. Let's double check that 2 is actually true. F of x is decreasing on the interval. Okay, I'm going to use the same chart. If f of x is decreasing, that means that f prime has to be negative. And yes, f prime is negative. This pink that I'm drawing right now, that is f prime. Just tracing it, and it is negative below the x-axis. So that is true, which means that D, yes, is our correct answer. Questions on these? All right. I'm not going to redraw the picture or take a picture for the next set, but what I want to talk to you about on number 8 is we are pretending that this f prime graph is velocity. Okay, so let's say that this graph is velocity. V of t. If you take a derivative of that, you get a of t. If you take an integral, you get p of t. Okay, so move down, it's derivatives. Move up, it's integrals. So everything that we've said about f of x, f prime of x, and f double prime of x applies here. Everything we've just said. Looking at that PDF of number 8, the first question is, from number 6, what does f of 5 represent? So f of 5 here would be a position. F of 5 is the position, P of 5. Is the position at t equals 5 somethings. We should probably get some kind of a label here. I told you in problem 8 that the label for velocity is feet per second. So I'm going to put feet per second for velocity, which means that position is labeled in feet. Acceleration is feet per second squared, and time, t, is measured in seconds. Okay, from part 1, what does concave up tell you? So if f is concave up, it told us that f double prime is positive. It also told us that f prime was increasing. So since position is concave up, that tells you that velocity is increasing. And second derivative, which is acceleration, is positive. We have a push in the positive direction. That's all that tells us. So by writing out these charts, you've done all your thinking and it's all organized, and then your job is to pull the information off of the charts. 7 part 2, if f of x is decreasing, what does that tell you? Okay, so if your position is decreasing, that means you're moving to the left. If position is decreasing, then we know velocity is negative, and the particle, whatever it is, the object, is moving to the left. Okay, how would that show up on the graph of velocity? Well, we said velocity is negative, so this would be negative on the graph, which is below the x-axis. Cool. Last question that we are asked from this is, what are the -3 and the 1 from that integral? The -3 and 1 are times. So it looks like this would be like we're going backwards in time to -3. So if this were like 0 is the year 2000, then -3 would be like 1997. And 1 would be 2001. So it's not like the greatest example, because usually our times are all positive. Okay, the -6. That one's kind of a tougher one. -6 is the difference between two positions, right? Because we're taking the integral of velocity. The integral of velocity is position, and we're subtracting two positions. We call that a net distance. That the particle travels between -3 and +1. Since we traveled a net distance that was negative, that means we have ended up to the left from where we started at. Since it's a distance, distance is all position-like, its label would be feet. And there it is, that's number 8. So there are definitely problems where you will have to do this kind of thinking, but it won't be all worded like this. It'll be worded like within the problem. If position is decreasing, what is the velocity? Something like that. This is more like your AP problems, where it tells you to find something, but it doesn't give you like, here's the function that you're supposed to take the integral of. Just do it. It has you analyze stuff. Any questions on 8? Okay, we've got about 8 minutes left. I definitely want to make sure we hit number 11. So let's jump to 11. And then we'll come back and do whatever we can. Oh, we get out at 11:15? We sure do. Okay, so we're doing number 11, and that's definitely going to be it. All right, 11 is the integral from a to b of f of x dx equals a plus 2b, then what is the value of the integral of f of x plus 5 dx, which is also from a to b? So some things to notice. We have the f of x function that's in both of those. Both of our functions start at a and end at b. Okay, so a is on the bottom and b is on the top. That's important. If one of them was flipped upside down, then we would have to flip it back upside down and make it negative. We do not have to do that. What we can do is we can split up that second integral to go from a to b of f of x dx plus the integral from a to b of 5 dx. Okay. We know that their first integral, I'm going to put this guy in purple, this integral right here is the same thing as this guy. So we can use substitution to replace that integral with a plus 2b. Okay, and then the last integral is the integral of 5. The integral of 5 is 5x, and we're going to evaluate that from a to b. This is our bracket thing. So this is going to be 5b minus 5a. And then we combine some like terms. Okay, so it's these two combined together would be 7b, and these two combined together would be negative 4a. And that's our final answer there. All right. Any questions? Anything last minute questions? Okay. I will see you guys on Monday.